Imagine two particles as tiny as you can possibly imagine. These particles are so small that they are invisible to the naked eye and can only be observed with the most advanced scientific instruments. Now imagine these particles are linked in a way that defies our everyday understanding of connection. When something happens to one, the other reacts instantly, no matter how far apart they are. This is quantum entanglement, a phenomenon that challenges our conventional notions of space and time. It's one of the strangest and most fascinating phenomena in the universe, captivating the minds of scientists and enthusiasts alike. Even Albert Einstein, one of the greatest physicists of all time, called it spooky action at a distance, highlighting its mysterious nature. In the quantum world, particles like electrons and photons behave differently than objects we see in our daily lives. They follow rules that seem counterintuitive and bizarre. They exist in a state of uncertainty, meaning we can't know both their position and momentum at the same time. This is known as the Heisenberg uncertainty principle. It's like they're playing hide and seek with our instruments, always eluding precise measurement. But here's where it gets really weird. The behavior of these particles can seem almost magical. When two particles become entangled, their fates become intertwined in a way that is difficult to comprehend. Measuring the state of one particle instantly determines the state of the other, even if they are billions of light years apart. This instantaneous connection defies the speed of light. It's as if they are connected by an invisible thread that transcends space and time, linking them in a profound and mysterious way. This isn't just a theoretical idea, it's a concept that has been rigorously tested and validated. Scientists have performed experiments demonstrating entanglement with photons, electrons, and even larger molecules, pushing the boundaries of our understanding. These experiments have confirmed the predictions of quantum mechanics, showing that entanglement is a real and measurable phenomenon. The implications of this are vast and still being explored. Let's dive a little deeper into the principles behind this mind-boggling phenomenon. Quantum entanglement is one of the most fascinating and perplexing aspects of quantum mechanics. Imagine you have two coins, and you flip them simultaneously. Each coin flip is an independent event. There's a 50-50 chance for each coin to land on heads or tails, right? The outcome of one coin doesn't affect the other. Now imagine these coins are entangled. This means their states are linked in such a way that the outcome of one coin is directly related to the outcome of the other. If one coin lands on heads, you instantly know the other coin landed on tails, even if they're miles apart. This connection defies our everyday understanding of distance and separation. It's as if they're communicating with each other faster than the speed of light. This instantaneous connection is what makes entanglement so intriguing. But here's the catch. They're not actually communicating. There's no signal being sent between the particles. In the quantum world, information can be shared instantly between entangled particles, regardless of distance. This phenomenon challenges our classical notions of space and time. This instantaneous connection is what makes entanglement so different from anything we experience in our classical world. It opens up new possibilities for quantum computing and secure communication. Think of it like this. Imagine you have a pair of gloves, one right-handed and one left-handed. They are a matched pair, just like entangled particles. You put each glove in a separate box and send them to different parts of the world. Despite the distance, their relationship remains intact. If you open one box and find a right-handed glove, you instantly know the other box contains the left-handed glove. This analogy helps us grasp the concept of entanglement in a more tangible way. Now let's talk about consciousness. What is it? How does it arise? These questions have puzzled scientists and philosophers for centuries. These are some of the biggest mysteries in science, and they remain largely unsolved despite significant advancements in our understanding of the brain and the universe. Some scientists believe that quantum mechanics, the same theory that explains entanglement, might hold the key to understanding consciousness. This idea suggests that the strange and counterintuitive principles of quantum physics could be at play in our own minds. The human brain is an incredibly complex organ with billions of neurons firing electrical and chemical signals. These signals create the intricate web of activity that underlies our thoughts, emotions, and perceptions. Could quantum processes be happening within these neurons? This is a question that has intrigued researchers for years. Could entanglement play a role in how our brains process information and generate consciousness? If so, it would mean that our thoughts and experiences are deeply connected to the fundamental workings of the universe. One theory suggests that consciousness arises from quantum interactions within microtubules. tiny structures found inside brain cells. These microtubules could be the site where quantum phenomena influence our mental states. These microtubules could act like quantum computers, processing information in ways that classical computers can't. This would mean that our brains are capable of computations far beyond what we currently understand. Another theory proposes that consciousness is a fundamental property of the universe, like mass or energy. This perspective suggests that consciousness is woven into the very fabric of reality. In this view, consciousness is not something that emerges from matter, but rather something that exists alongside it, permeating all of existence, and perhaps even influences it. This idea challenges our traditional understanding of the relationship between mind and matter, opening up new possibilities for exploring the nature of reality. As we delve deeper into the intersection of quantum physics and consciousness, we are on the brink of potentially revolutionary discoveries. If quantum phenomena indeed play a role in our conscious experience, what could this mean for the future of science, technology, and even our everyday lives? Imagine advancements in artificial intelligence that incorporate principles of quantum consciousness, leading to machines that can think and feel in ways that are currently beyond our imagination. This could usher in a new era of AI where machines not only process information, but also experience a form of awareness. In medicine, understanding the quantum nature of consciousness could revolutionize mental health treatments. We might develop new therapies that target the quantum processes within our brains, offering more effective solutions for conditions like depression, anxiety, and neurodegenerative diseases. Furthermore, this research could have profound philosophical and spiritual implications. If consciousness is indeed a fundamental aspect of the universe, it might reshape our understanding of our place within it. We could begin to see ourselves not as isolated individuals, but as deeply interconnected beings, part of a vast conscious cosmos. These ideas are still in their infancy, and much research is needed to explore and validate them. However, the potential is vast, and the journey of discovery promises to be one of the most exciting frontiers in science. Thank you for watching. Don't forget to like and subscribe to the channel. Stay curious and keep exploring the mysteries of the universe.